start. This is Iit Jam, yeah, 2021, problem 10. Okay, so A is a n by n complex matrix. Okay, yeah. So if a to the power n is equal to identity, okay, a to the power k is equal to identity for some k greater than or equal to 0, and what can we say about the eigenvalues? Right? So think about it, and then we do. First, tell me some guesses and things. You can ignore this thing. So yeah, try to make some guesses that, or take some small examples and guess. I mean, your examples should not be too simple, otherwise you will not know. Otherwise, your output will be too simple to understand anything. Sorry. So, any guess for 2 by 2 case if you have tried? So I'm trying to just approach slightly that you should do more of the work. I think that way, yeah. Let's do it and see. So what I was going to say is, can you tell me what happens if k is equal to 0? Then what can you say? about the eigenvalues? K, values of K and eigenvalues. N is arbitrary. Maybe I can also, yeah, you can see.
If k equal to 0, then the
Then
eigenvalue will be 1.
so that is your guess, right? That is correct. Now, if K is equal to 0, it implies A is equal to identity. That implies eigenvalue is equal to 1, right? Identity matrix has only one eigenvalue, which is which is 1, right? Yeah. So that is an absolute triviality. This is what happens. Like if I take this case, you don't learn anything, right? So that's why let's take or I mean, if you take K equal to 1, then also you don't. Okay, yeah. So no, sorry. No, so I said something wrong. Can you say what I said wrong? If A to the power 0 is equal to identity, right? What can you say about the eigenvalues? Nothing, because this is always true, right? Yeah. So that's why
Yes.
that's absolute triviality. Vaishnavi, is it fine? Are you? Oh, she's not there.
वो नहीं है
Oh,
अभी
okay,
लेट
okay.
हूँ.
All right. Okay. So then at that time you can say nothing. So that's why we should say that this is basically actually the question. This was not there. I wrote it by mistake. Yeah. If K is equal to 1, then what can you say? That time you can say that the eigenvalue is only 1. Now you tell me what happens when K equals to 2.
Then lambda square equal to 1, so lambda will be 1 and 1.
Right. So you're saying this implies lambda square equals to 1. Can you prove that? How would you prove that?
यहाँ पे कैरेक्टरिस्टिक इक्वेशन लिखना पड़ेगा।
You can you can prove it in any way you want. But if you ask me, I would say you don't need to take characteristic equation because बस definition use करो. Lambda is an eigenvalue of A. Write it and use the definition, right?
लैम्डा अगर उसका आइगन वैल्यू हो रहा है तो ए माइनस लैम्डा ए स्क्वायर इक्वल टू आयन वाला सेटिस्फाई करना चाहिए।
You can take that definition, but why don't you take this definition? AV equal to lambda V, right? You can yeah, you can take that definition. So what is the definition you're taking? That lambda will satisfy this, the characteristic polynomial. But there is I mean, I don't understand it completely because okay. So an is equal to lambda, a square is equal to in. So lambda is an eigenvalue. A. You are saying that lambda square equals to -1. Sorry, lambda square. Yeah. My question is why? Can you explain? So you use the definition that lambda is a root of the characteristic polynomial but what is the characteristic polynomial? Do you know what the characteristic polynomial is?
यस ए माइनस लैम्डा इक्वल टू उसके बाद जो मिलेगा पॉलीनोमियल ये है।
Okay, right. So that is the definition, right? No. I did not ask like that. I meant I know I know you know what is characteristic polynomial. I'm not saying that. I wanted to know that in for this A, what is the characteristic polynomial? This is the definition that you know. Fine, I know that. But what is the characteristic polynomial in this case? Can you say it is a square? Can you say it is whatever x square minus 1? No.
इसका कैरेक्टरिस्टिक इक्वेशन होगा ए माइनस लैम्डा होल स्क्वायर इक्वल
A minus lambda I whole square equals to 0.
सॉरी
Right? So what is the definition of characteristic? The definition of characteristic polynomial is this. So now how will you say that it is equal to something which you want to say? You want to say maybe, I don't know what you want to say. Lambda square minus 1, or maybe we'll put x here maybe. If you want to say it is x square minus 1, but is it x square minus 1? No, right? So you should think about this matter. There is something which there is a conceptual mistake, right?
that is determinant of A minus lambda equal to 0. That's the characteristic equation.
Yes, that's the characteristic equation, right? But then
But
how does it help
I
you to do
was
the problem?
solving to
Hmm?
let me think.
No? So the problem is, see, you know the definition, but the problem you are facing is what you want to say will not be true. Means you cannot say that x square minus 1 is a characteristic polynomial. That is not the characteristic polynomial, right? Simply because the characteristic polynomial has to be degree n. So how can that be the characteristic polynomial? Fine.
नहीं समझ नहीं समझ नहीं समझ.
Okay, so anyways, so okay, so let's say that there are some confusions you're having with characteristic polynomial, okay. But keeping that aside, how do you proceed with the problem? Right. Let's say you're solving the problem in an exam. How do you proceed with the problem? We'll keep that aside and see. Come back to that later.
मैंने क्या करा कि, a minus determinant of a minus lambda equal to 0. That will be the characteristic polynomial. And if
A
lambda is the root,
minus lambda equal to 0.
a minus lambda I, determinant of a minus lambda equal to 0. That's the polynomial.
This is not a
Now,
polynomial. How is this a polynomial?
the
Determinant of this.
determinant of a minus lambda I equal to 0. That's the characteristic polynomial.
Okay. Okay.
Now, if lambda is the root of the if lambda is the root of the matrix,
Matrix. Root of a matrix.
determinant of this.
Okay. Root. So that's the problem is you're using. You should say this is a polynomial. Otherwise, you say root of the equation. Yeah. Anyways. Okay. If lambda is the root of this, all right.
Then there is a given equation s square equal to y n.
There is a given equation a square equal to in.
I just put that a minus lambda I in spite of a square equal to I.
You put a minus lambda I.
Whole square equal to I.
A minus lambda I whole square equal
Equal
to,
to I.
what is the last thing you're saying? Equal to what?
Yeah. Hello?
Equal to what?
Equal to uh, yes, equal to I was saying.
Why?
It should be I or 1.
Is it a number or a matrix? That you have to think. I don't know. It cannot be one, right? It has to be a matrix. It has to be I. If you're using I for a matrix, it has to be I. I mean, I is the only option. But is it I? On what basis is it I?
I just put it in that equation.
Which equation? Equation 1.
That is equal to I.
This equation.
Yes.
But what can you put in this equation? This equation you cannot put anything, right? There's no variables in this equation. I mean, are you putting in this equation? In this equation you cannot put anything because there are no variables. It's just a sentence. It's not a, I mean, whatever. I mean, there's no question of true or false in this. You can say it's an identity. There is nothing to put there. That's clear. Right? So it doesn't work. Doesn't work. So see, I just want to know why is this plus minus 1? You told me it's plus minus 1, and let's say I'm telling you that it is true. Just prove it to me that it is plus minus 1. You use anything you want, but it should be correct. You can use just the definition. You can use a 2 by 2 matrix, write it, expand it, and show. Okay? Yeah. The problem is that this equation, I can tell you one thing, that this equation that is given, this is just given that A satisfies this. Okay. And this is a polynomial, right? These two things, I mean, at the moment don't seem to have any connection, right? At least what I can understand. These two things don't seem to have any connection. Okay, if you are using Kelly-Hamilton theorem, then you might want to say that chi of A is equal to 0. But again, how does that help you to know what is lambda? I do not know. Chi of A equal to 0 is Kelly-Hamilton theorem, right? You can also just say I can put A here, but that's obviously a wrong proof. But anyways, the end result is correct. That's the theorem. So we take that. But that doesn't help me to understand what is lambda, right? So just tell me what is lambda. You may or may not know Cayley-Hamilton theorem, but tell me what is lambda. Why is lambda plus minus 1? Right? So just use. See, the point is the characteristic polynomial will not help you here too much. Does it? It will not help you too much because that's going to be an n degree equation, right? Is it going to help you? I don't know. It can help you, but then you have to use something else. But no point. Right? So just use the definition. Try to, so okay, I'm telling you that, okay, do it from the definition. Use the definition of eigenvalue, right? Just use a definition that there is a V such that AV is equal to lambda V. Use this definition and try. Okay, that you should try. Yeah, I hope you get some clarity on that characteristic polynomial usage. Just because some equation is given, it doesn't mean it's a characteristic. It doesn't mean that it's a characteristic polynomial. Means it doesn't mean that x square minus 1 is a characteristic polynomial and a is put there. It doesn't mean that. There can be many equations that a matrix satisfies. So you can do this. You can say minimal polynomial and this that, but there is a direct proof also which you should try. Okay. No? Okay. So see, what is happening is very simple. A V equals to lambda V, right? You want to say that lambda square is 1. So how do you bring lambda square here? You want to show something, but uh, and the point is that involves something that involves lambda square. So you have to think about bringing lambda square in the picture. Then everything will automatically cap. So how do you do that? Well, just multiply by a on the left, right? And multiply by a on the left, then you get this, right? And then you get this. And this AV is lambda V. So you get this, right? So you get a square V equal to lambda square V, which means a square is an eigenvalue of lambda square. Maybe this is what you wanted to say also. That if a is an eigenvalue of lambda is an eigenvalue of a, then lambda square is an eigenvalue of a square, things like that, which should happen. But then a square is equal to identity. So this basically means that lambda square is equal to 1. Correct? Because you know the axioms of vector space, right? A scalar times a vector is equal to 0. It implies that You know that, right? That either C is equal to 0 or, well, these are all very concrete objects, but in general vector spaces, you know this. C is equal to 0 or B is equal to 0, right? Not field, but you understand, right? Vector space field, because you have a C inverse if C is not equal to 0. So that's just a thing which you have, so just use it. That's it, and so this implies. Okay, so this is all. There is nothing here. This is all. So yeah, so why don't you think about the general case, and we meet after some time and discuss it, right? Think about the general case. What should the answer be? What can you say about the eigenvalues? And the other question which is there, part of the same question, is let me just confirm it. If all eigenvalues of A are kth root, this is part B, kth root of unity for some k, right? Then is A to the power k equal to In?
Kth root of unity means
Kth root of unity means that number which, when x such that x to the k is equal to 1. There are k such numbers, right? Complex numbers. And those k numbers are called kth roots of unity. They are kth roots because when you raise them to kth power, you get back 1. 1 is unity. Okay. Yeah.
just
Actually,
1 minute, let me write the question.
yes. This is the definition you need. You don't, yeah, x to the power k is equal to 1. This is a um, complex matrix, remember. Okay, complex matrix. This is also important. Now take your time, think about it, come back in 10 minutes and see